So in this particular question, we have R, which represents the set of all real numbers. And we have to find the meaning of the Cartesian product of R with itself and the Cartesian product of R with itself 3 times. So let us begin by writing down that R represents the set of all real numbers. So we can take few examples. This is a very big set, so let's take some positive integers, some negative integers, some rational numbers as well as some irrational numbers. So the Cartesian product of R with itself is going to give us the set of ordered pairs, some set of an ordered pairs. Now what we have to do, we have to choose the elements that will form the ordered pair. Now we could do is like we can consider x comma x such that x belongs to the set of real numbers. However, this is going to restrict us. This is going to restrict us with the choice of values. Now instead of x only choosing x, what we are going to do here is we are going to expand it. We are going to actually consider another number y such that x and y are both picked up from the set of real numbers. So meaning x could be this 3. The choice is completely arbitrary, so we are considering it as x. So let me and square root of 2 could be y. Necessarily we could the choice is completely arbitrary, so x has to be a real number. It could be picked up from this set and it could comprise of any number. So this if we remember from a Cartesian plane, let's draw a Cartesian plane. So we have the x-axis and the y-axis. So we can locate a point, and each of this point is going to represent an ordered pair. So let's say that the first point is representing x1, y1. This point is representing x2, y2. The third point is x3, y3. And the fourth point is x4, y4. So these are the different points that can be located on the Cartesian plane, and that is what is the meaning of r cross r. This is also simply equals to r squared. So this is a two-dimensional space that we're talking about. Now if we are to choose, like initially when I say it, like we could have chosen the arbitrary this ordered pair as x comma x. So that would mean like we are restricting our values to points which would only represent the points lying on the line. Meaning, let's say if we choose x to be equals to 1, then the ordered pair would be simply 1 comma 1. If we assume x to be equals to negative 2, then we have the ordered pair negative 2, negative 2. Let's take another one, x equals to 5, then the ordered pair corresponding to it will be 5 comma 5. And that would mean that, let's draw another Cartesian plane. That would mean that we are picking up the values. So this is 1 comma 1. Another one will be negative 2. This will be negative 2 comma 2, negative 2 comma negative 2. And another point will be 5 comma 5. So if we draw a line, if we draw a straight line, then the straight line is going to pass through this point and through the origin. So that means when we consider the order pair represented by x comma x, then it's only going to take care of the points that lie on this straight line which is passing through the origin. So what about the other points lying above and below the line? So in order to take care of that, so we have considered a second element y, which also represents the set elements belonging to the set of real numbers, and that is the meaning of r cross r. Now for the second part, we have the Cartesian product of r with r and then again with r. So this will represent the set of ordered pairs given by x, y and z, such that these elements x, y and z all belongs to the set of real numbers. Now this maps out the points that can be located on a three-dimensional space. So this is more spatial, and it can be written in a condensed form as r raised to the power of 3. So here 3 represents that we are talking about a three-dimensional space. So this represents points in space, and r square represents points in a plane. So that's it. So this is the Cartesian product of a real number with itself once and twice and thrice. Let's move on to the next question. So here in this question we have the Cartesian product of a and b, and the elements which are represented by the ordered pairs a1, a3, a7, b3, b7 and b1 are provided. So using this information we have to find out the Cartesian product of b with a and the elements present in set B. So what we do is, in order to find out the value of b cross a, what we do is we take the elements in a cross b. Now let's consider the element, the first element or the first ordered pair, which is a comma 1. Now we're going to flip. That means we are going to flip the values of the abscissa and the ordinates. So that means the abscissa here is 1. So when we flip it, it becomes 1 comma a. So similarly we can do to the second ordered pair. So we have a comma 3, so that will become 3 comma a. The third one will be 7 comma a. The fourth one will be 3 comma b, and then we have 7 comma b and 1 comma b. So this is the Cartesian product of b and a. What we have simply done is, like, we have flipped the elements in the ordered pair. Now we have to find out the elements present in b. So b corresponds to all the elements appearing in the abscissa. So if we look at b cross a, the elements appearing in the abscissa are 1, 3, 7, and we have 3, 7, 1. While writing a set, we generally don't repeating elements, so we simply have 1, 3 and 7. So these are the elements that belongs to set B. Now we can also find out the elements that belongs to set A. We look at either B cross A, or we can look at A cross B. Since we are doing B cross A, let's look at that. So the elements present in A will correspond to all the elements that are present in the ordinate. So the ordinate values are, so we have A. So this is one of the ordinate, and we have B. Since we're repeating 3 times, we only need to write it once. So these are the elements A and B that's present in the set A. Let's move on to the next question. So here in this question we have the element x, which belongs to the set containing the numbers -1, 2, 3, 4 and 5. Then we have another element y, which belongs to the set containing the elements 6, 0 and 3. Then we have to write the set of all ordered pairs x, y, and it has to follow the rule that the sum of the two elements x and y is equals to 5. So let us begin by considering the value of x. Let's pick up the first element, which is -1. So when x is -1, now we are going to use the equation that's provided to us. We have y is equals to 5 minus x. So let's substitute the value of x. So that is -1, so that gives us 5 minus of -1 is 5 plus 1, which gives us 6. Now we see that 6 actually belongs to the set 6, 0, 3. So that means the ordered pair -1, 6 is valid. So we'll stick to it, this one. Now let's take the second element, which is 2. So x equals to 2 will give us y equals to 5 minus 2, which is equals to 3. we see that 3 also belongs to our set 603. So the element 3 belongs to this set, so that means this is valid. So that means 2 comma 3. So this is a valid ordered pair. Let's go to the third element. We have x equals to 3. So that gives us y is equals to 5 minus 3, which is equals to 2. Now we see that 2 does not belong to the set 603. So this means this ordered pair 3 comma 2 does not exist. Now we go for the fourth one. So we have x equals to 4. So that will give us y value to be equals to 5 minus 4, which is equals to 1. Again we see that y does not, or 1 does not belong to our set 603. So the ordered pair 4 comma 1 does not exist. It exists, it's just that it's not going to belong to the Cartesian product. And for the final element, we have x equals to 5. So that gives us y is equals to 5 minus 5, which is equals to 0. And now we have this element belonging to the set 603. So this implies that the ordered pair 5 comma 0 is valid. So we have to write the set of all ordered pairs that follows x plus y equals to 5. So let's call this set as A. So this set A contains the ordered pair. So the first one is -1, 6. Then we have the second one, which is 2, 3. And the third one, which is 5, 0. So this is the answer. Let's move on to the next question. So here we have the element x, which contains the element x belongs to the set containing the elements 2, 4, 6 and 9. Y is another element containing belonging to the set that contains 4, 6, 18 and 27. Now we have to write the set of all ordered pairs x and y such that x divides y and x must be less than y. Okay, let's begin. So let's start with y. So we have y belongs to the set containing 4, 6, 18 and 27. So let's start with y equals to 4. Now we're going to pick up some values from the set 2, 4, 6, 9 such that a particular element is going to divide y. So if we pick up x equals to 2, also we have to follow that x is going to be less than y. So we have x equals to 2 and we know that this 2 is less than 4. So this is valid. Now let's check if 4 is divisible by 2. Yes, 4 is indeed divisible by 2. So that means we have our first ordered pair, so that is going to be x, which is 2, and followed by y, which is 4. So this is one valid ordered pair. Now for the same y equals to 4, we will not be able to pick up any other values of x, because if we pick up the value of x equals to 4, then it is not going to be lesser than y equals to 4. So this is the only ordered pair that we are going to get for this particular combination. Let's take the second value, y is equals to 6. Now we'll pick up the first value of x equals to 2. We have seen that x is less than the value of x is less than 6. So this is valid. The first condition is fulfilled. Now we also notice 6 is divisible by 2. Because 6 divided by 2 gives us 3. So we have our second coordinate pair. So second ordered pair, or the coordinate pair. So this will be x is 2 and y is 6. Now for the same y equals to 6 value, we cannot consider x equals to 4. Because even though it's satisfying the first condition that x is less than y, because 4 is less than 6, but 6 is not divisible by 4. So we cannot consider the value of x equals to 4. When you come to the value of x equals to 6, the first condition itself is not fulfilled, where 6 is not less than 6. So we move on to the next number, which is y is equals to 18. Now clearly 18 is divisible by 2, so we have x equals to 2, which is less than 18, so the first condition is fulfilled. Also we see that 18 is divisible by 2, so we have the third coordinate pair, which is 2, 18. Then we take the next value for x is equals to 4. Now 18 is not divisible by 4, so we have to skip it. Then we go to 6. Now 6 is also less than 18, and we know that 18 is divisible by 6. This time it's divisible by 6. So we have the fourth coordinate pair, or the coordinate point, which is 6, 18. Now for x equals to 9, we see that the condition is fulfilled. It's lesser than 18, and also 18 is divisible by 9. So we have another ordered pair, which will be 9, 18. Then we'll go to the final value, which is y is equals to 27. So we see that for the values of x equals to 2, 4, and 6, 27 is not divisible by each of them. So we are left with only the last element, which is x equals to 9. So the first condition is fulfilled, that line is less than y, and 27 is divisible by 9. So we have the final ordered pair, which is 9, x is 9, and y is 27. So we have the final the final set, let's call it A, will be the set containing the ordered pairs 2, 4, 2, 6, 2, 18, and we have 6, 18, 9, 18, and 9, 27. So this is the set containing all ordered pairs, which follows the condition that the x which is the abscissor is going to divide the ordinate, that is y, and also the abscissor value is less than the ordinate value. Let's move on to the next question. So here we have three sets, A, B, and C. A contains the elements 1, 2, and 3. B contains 3 and 4, while C contains 1, 3, and 5. So we have to verify that the Cartesian product of A with B union C is equivalent to the Cartesian product of A and B union the Cartesian product of A and C. So let's begin with the first part. So we'll start with the left hand side. So we'll first try to find out B union C. So B union C will be the set containing elements 3, 4, union 1, 3, 5. So we know that union means we have to take all the elements present in both this set. So we have 1, 3, 4, and 5. So this is the value of B union C. Now we're going to find out the Cartesian product of A with B union C. So we have A, which is 1, 2, and 3, cross B union C, which is 1, 3, 4, and 5. So let's find the set of ordered pairs. So we'll begin with the first element in set A. So we'll have 1, comma, and then we'll pick up one by one each of the element of the second set, which is B union C. So we have 1, 3, comma, 1, 1, comma, 1, 4, comma, 1, 5, comma. So this is over. Now we go to the second element of set A, which is 2, and then one by one pick up all the elements from the second set. So we have 2, 1, 2, 3, 2, 4, 2, 5. And for the final element in set A, we'll have 3, 1, 3, 2, 3, 3, 3 4 and 3 5. So I've listed out all the ordered pairs. Now we move on to the right hand side. So this is the left hand side. Now we'll go to the right hand side. And running out of space here. Okay, fine. So let's find out first A cross B. So A cross B will be 1 2 3 cross 3 4. So that will be, let me quickly write it down. So we have 1 3 1 4 2 3 2 4 and 3 3 3 4. Then we'll find out A cross C, which is simply the Cartesian product of set containing the elements 1 2 3 and 1 3 5. So that should give us 1 1 1 3 1 5 2 1 2 3 2 5. And we have 3 1 3 3 and 3 5. Now we have to find the value of the union, so let's do that. So now we have to find the union of the Cartesian product of A and B and A and C. So let's pick up 1 3 first. So 1 3, so let's see if it is repeating here. Oh yeah, it's repeating. So the first value is 1 3. Then let's pick up 1 1. So we have 1 1 repeating once. Okay, so we have 1 1. Then we go to 1 4. So we have 1 4. Is it repeating anywhere else? No. So we have 1 4. Then we have 1 3. We have already taken care of it. Okay, we have already taken care of it. Then we move on to 2 1. 2 1 2 1. Yes, so we have a 2 1 here. And we look for 2 3. So there's a 2 of them. 2 3. Then we go for 2 4. So 1 2 4 here. So that's the only one. Yeah. 2 comma 4. Then we go for 2 5. So we have a 2 5 here. Then we go for 3 1. So we have a 3 1. Then we go for a 3 3. So we have 2 of them. So that will amount to only one element. 3 3. Then 3 4. 3 4. And then finally 3 5. There's one more element that's remaining, so that is 1 5. And I think I made a mistake. It's not a mistake actually. That is 1 4. This is 1 5. So this is also taken care of. Now here we have 1 1 4. One was repeating. 2 1 2 1. What was it? 1 3 1 1. So we have 1 2 3 4 5 6 7 8 9 10 11 12. 12 elements. So 3 4 5 6 7 8 9 10 11 12. Oh, that's fine. So we have 12 equal elements in both. So this verifies that left hand side is equals to right hand side. Now let's work with the second part. So this time let's begin with the right hand side. We can use the result from the previous one. So let me pull it up. So this was the result that was obtained in the previous question. So we already have the values of A cross B and A cross C. So let us try to find out the intersection of the two Cartesian products. So we have A cross B intersection A cross C. Now intersection means we have to pick up the common element present in both the two sets. So let's look for it. 1 3. So we have 1 3 present. So this is going to be our first ordered pair. 1 4, is it present? 1 4 is not present. 2 3. So 2 3 is present in both the two sets. 2 4. 2 4 is not present. 3 3 is present. I think that's it. So these are the three ordered pairs in the intersection of the two Cartesian products. Now let's begin by doing B cross C. So this is our right hand side. Now we'll start with the left hand side. So we have B intersection C, which is equals to 3 4 intersection with the elements 1 3 5. So 3 is the only common element in both the two sets. So this value is equals to 3. Now find out the value of A, Cartesian product with B intersection C, and that is simply 1 2 3 with 3. So that gives us 1 3 2 3 and 3 3. So this is the left hand side, and we see that the left hand side is equals to the right hand side. So these two identities now hold. It holds.